Mention the names of the metals for the following. The two metals which are alloyed with iron to make the stainless steel. The one is the chromium, another one is the nickel. The two metals which are used to make the jewelry, gold and the platinum. State three reasons for the following facts. Sulfur is a non-metal, magnesium is a metal. One of the reasons must be supported with a chemical equation. Okay. So sulfur is a non-metal, magnesium is a metal. So always the non-metals, they do not conduct the electricity because they do not have any free ions or the electrons. So the sulfur is a poor conductor of heat and the electricity. Magnesium is a metal, so which is a very good conductor of electricity and the heat. So sulfur is neither malleable nor ductile, whereas the magnesium is malleable and ductile. Sulfur burns with the oxygen and forms the sulfur dioxide. So this sulfur dioxide, when dissolves in the water, will get sulfurous acid H2SO3. So sulfur dioxide is an acidic oxide because it gives acid. Magnesium burns in the air will get the magnesium oxide. So the magnesium oxide when dissolves in the water will get the magnesium hydroxide, which is basic in nature. Always the metallic oxides are basic oxides and non-metallic oxides are acidic oxides. What is cinnabar? How is metal extracted from cinnabar? Explain briefly. Cinnabar is nothing but the HGS. So the mercury is obtained by roasting the cinnabar. So HGO is formed as thermally unstable and gives the mercury. So 2HGS when burns with the air will get HGO plus SO2. So when the HGO, when we are heating it, it will liberate the oxygen gas plus mercury. So this HGS when it burns in the air, so Hg plus SO2. So this we can use it, but the mercury can be purified by the distillation method. Write the electron dot structure of potassium and the chlorine. Show the formation of the KCl by the transfer of the electrons. Name the ions present in the compound KCl. Okay. So now the potassium and the chlorine. So the potassium is atomic number is 19. So the number of the electrons are 19. So we can split that, the 2 electrons in the first shell, 8 electrons in the second shell, the 8 electrons in the third shell and 1 electron in the fourth shell. Chlorine, which is having atomic number 17. So the number of electrons are 17. So the first 2 electrons placed in the first shell, the next 8 electrons placed in the second shell, the 7 electrons placed in the third shell. So how the formation of the KCl will happen is, so the potassium is having the only 1 electron in the outermost shell. If it lost the 1 electron, it becomes the stable outermost shell. So at the same time, the chlorine is having a 7 electron in the outermost shell. It needs 1 more electron to gain to make the element more stable. So this 1 electron is transferred from the potassium to the chlorine. So the K becomes the K plus by the loss of the 1 electron. At the same time, the Cl atom gains 1 electron from the potassium and it forms the Cl minus. So the K it loses the 1 electron to the chlorine and it forms a K plus and it's a Cl minus. So the formula is KCl. Name the ions present in the compound. So it's a K plus and the Cl minus. State the electron dot structure for calcium and the sulfur. Show the formation of the CAS by the transfer of the electrons. Name the ions present in the compound CAS. So the atomic number of the calcium 20 and oxygen 16. So the calcium is 2882. The atomic number is 20. So we have placed the 2 electrons in the first shell, 8 electrons in the second shell and 8 electrons in the third shell. and 2 electrons in the fruit shell. So the sulfur is having the atomic number 16. So there are 16 electrons in the totally they are having 16 electrons. So 2 electrons in the first shell, 8 electrons in the second, and 6 electrons in the third shell. So now the calcium is having the 2 electrons in the outermost shell. So the calcium can able to lose the 2 electrons. At the same time, the sulfur can able to gain the 2 electrons. Then it can complete the outermost shell. So the calcium loses the 2 electrons and it becomes the Ca2 plus. Then sulfur gains the 2 electrons and it becomes the S2 minus. So the calcium loses the 2 electrons to the sulfur atom and it forms the Ca plus 2 and the S2 minus. So these are all the ions Ca2 plus and the S2 minus ions present in the calcium sulfide. Write the electron dot diagram for chlorine, so which is having atomic number 17 and the calcium atomic number 20. Show the formation of the calcium chloride by the transfer of the electrons. Okay. So now the calcium is having a atomic number 20. So 2882. So there are 2 electrons in the outermost shell. So the chlorine is having the 17 electrons, so 287. It needs 1 electron to complete the shell. Okay. So now in this case, the calcium can lose the 2 electrons, but the chlorine can able to gain only 1 electron. So one more electron is left out in the calcium. So one more chlorine atom we can add. So that will gain the other electron. So Ca loses the 2 electrons and it becomes the Ca plus 2. At the same time, the 2Cl atom can gain the 2 electrons and it becomes the 2Cl minus. So one electron from the calcium is moved to the one chlorine atom and one electron from the calcium is moved to the another chlorine atom. So it forms the Ca2 plus and the Cl2Cl minus. So the formula is CaCl2. So it's an ionic compound because it's having a charge. Its physical properties are it is a hard and solid. It has a high melting and boiling point. It is readily soluble in the water. So you are given the samples of the 3 metals, sodium, magnesium and copper. Suggest any 2 activities to arrange them in the order of the decreasing activity. Okay, so the activity number 1. The sodium reacts with the cold water and it produces the sodium hydroxide with the liberation of the hydrogen gas. And the magnesium does not react with the cold water because its reactivity is reduced. So due to that it does not react with cold water but it reacts with the hot water to form the magnesium hydroxide and the hydrogen gas. So Mg can able to react with the hot water and it forms the magnesium hydroxide with the liberation of the hydrogen gas. So hence proved that the sodium is more reactive than the magnesium. Then activity number 2. The magnesium plus copper sulfate gives the magnesium sulfate plus copper. So the magnesium is displays the copper. It means that the magnesium is more reactive than the copper. Okay. So in this reaction, copper plus magnesium sulfate, there is a no reaction because in reactivity series, the magnesium is present above the copper. It means that the magnesium is more reactive than the copper. So copper cannot able to displace the place of the magnesium. So there is a no reaction. You are provided with magnesium ribbon and sulfur powder. Explain with the help of the activity that metal oxides are basic and non-metal oxides are acidic in nature. Okay. The aim to test the nature of the oxides formed by the metals and the non-metals. Materials require sulfur powder, magnesium ribbon, water, blue litmus paper, red litmus paper. Procedure. So take the magnesium ribbon with a pair of tongs and burn it in the flame or in the presence of the air. Collect the product form and dissolve it in the warm water. Add red litmus paper into it. Observe the change in color and decide the nature of the oxide formed. Burn sulfur in the deflagrating spoon in the presence of the air and dissolve the oxide formed in the water. Dip the blue litmus paper into the solution and observe the change in the color and decide the nature of the oxide formed. Okay, so now the observation, the oxide formed by the metal turns the red litmus blue, so which indicates that it is a basic in nature, and while the oxide of the non-metal turns the blue litmus red, so which indicates that that is acidic in nature. So chemical reactions involved in this are magnesium burns with the oxygen and it forms the magnesium oxide. So when we are dissolved in the hot water, we'll get the magnesium hydroxide. So this shows the red litmus paper blue. So this indicates that this is the basic in nature. So at the same time, the sulfur, when burns in the oxygen, it forms the sulfur dioxide. The sulfur dioxide, when you are dissolved in the water, will get the sulfurous acid, so which turns the blue litmus paper red, so which shows the presence of the acid. Conclusion. So most of the metallic oxides are basic in nature, whereas the most of the non-metallic oxides are acidic in nature. An ore on treatment with dilute hydrochloric acid reduces the brisk effervescence. What type of ore is this? What steps will be required to obtain the metal from the enriched ore? Copper coin is kept immersed in the silver nitrate solution for some time. What change will take place in the coin and the color of the solution? Write the balanced equation of the reaction involved. Okay. So the carbonate ore is a calcination we have to do. So what is a calcination is the carbonate ore we have to heat it in the limited supply of the air and the oxide is obtained. See for example zinc carbonate we have to heat it. So it will convert that into the zinc oxide with the liberation of the carbon dioxide. Then we have to reduce it with the carbon. So the ZNO, zinc oxide, treated with the carbon, it forms the zinc plus carbon monoxide. So like this, we have to extract the medium reactivity metals. So copper, being the more reactive than the silver, will displace the silver from the silver nitrate solution and there will be the deposition of the silver on the copper coin. So for example, the Cu copper plus AgNO3 gives CuNO3 twice plus 2Ag. So the copper is more reactive than the silver, so that's why it's displaced the Ag metal. Okay, give reasons for the following. So school bells are made up of metals. Okay. It is because the metals are sonorous. So they produce a very good sound when struck with a hot substance. Electric wires are made up of the copper. So because the copper is a good conductor of electricity. Suggest a method of reduction for the following metals during their metallurgical processes. Metal A, which is one of the last, second or third position in the reactivity. Metal B, which gives a vigorous reaction even with water and the air. Okay, metal A. So the metal A can be obtained by the chemical reduction using the carbon or the carbon monoxide as a reducing agent, because the second and the third position we have to do only the reduction. So in the reactivity series, say for example potassium, sodium and all, they are high reactivity metals, so we have to extract only by the electrolysis. The metal B, which gives the vigorous reaction even with the water and the air. So it means that the B is present in the high reactivity series metals. So it has to be obtained by the electrolytic reduction. Metal C, which is kept in the middle of the reactivity series. So the carbon can be reduced by reducing agents like the Al. Okay. Define the activity series of the metals. Arrange the metals gold, copper, iron and magnesium in the order of their increase in the reactivity. The series of metals in which the metals are arranged in the decreasing order of the reactivity. Okay, so the gold, so which is the least reactive, then copper, then iron, then magnesium. So it's in the increasing order of the reactivity. So what will you observe when some zinc pieces are put in the copper sulfate solution? So we have to check in the reactivity series whether which metal is more reactive, zinc or the copper. So in this case, the zinc is reacts with the copper sulfate. So zinc is more reactive than the copper. So definitely it will displace the place of the copper. It forms zinc sulfate plus copper. So how do you observe this? Because so the copper sulfate solution is blue in color, that will converted to the colorless, and the copper will be deposited as a reddish brown precipitate. So what will you observe when some silver pieces are put into the green colored ferrous sulfate solution? Okay, so we have to check the reactivity series, which one is more reactive. Okay, so silver coin we are placing up in the iron ferrous sulfate. So iron is more reactive than the silver. So definitely the silver cannot able to displace the place of the iron. So there will be no reaction. Reaction will not take place as because the silver is less reactive than the iron. A green layer is gradually formed on a copper plate left exposed to the air for a week in a bathroom. So what could this green substance be? So it is due to the formation of the basic copper carbonate CuCO3 and the CuOH twice. Name the following. A metal which is preserved in a kerosene. So always the group 1 metals we have to preserve in the kerosene because they are highly reactive, sodium or potassium. A lustrous colored non-metal. So it's a iodine. It's a lustrous colored non-metal. A metal which can melt while kept on palm. Gallium. A metal which is a poor conductor of heat. Lead. Explain why the calcium metal, after reacting with the water, starts floating on its surface. Write the chemical equation for the reaction. Name one more metal that starts flowing after some time when immersed in the water. The calcium starts floating because the bubbles of the hydrogen gas formed stick to the surface of the metal. So calcium plus 2H2O gives CaOH twice plus H2 gas. So the magnesium, when it reacts with the hot water, it starts floating. So due to the bubbles of the hydrogen gas sticking to its surface. So give reasons for the following. Aluminium oxide is considered as the amphoteric oxide. Okay. So we know that the acidic oxide and the basic oxide. So this amphoteric oxide. So amphoteric oxide is nothing but it can able to react with the acids as well as the bases to produce the salt and the water. So aluminium is the less electropositive metal. So it forms the amphoteric oxide which can able to react with the acid as well as the base. Ionic compounds conduct electricity in the molten state. Ionic compounds can able to conduct the electricity in the molten state because the ions become the free to move in the molten state because it is in the liquid state. Explain the formation of the ionic compound CaO with electron dot structure. Atomic number of the calcium and oxygen are 20 and 8 respectively. Okay. So calcium, so its atomic number 20. So the electrons are 20. So 2882 is the electronic configuration. So it loses the 2 electrons which is in the outermost shell and becomes the 288. So oxygen, which is having the atomic number 8, so 2, 6 is the electronic configuration. So it needs 2 more electrons to complete the shell. So it gains the 2 electrons from the calcium and it forms the O2 minus. So Ca plus 2 and the O2 minus are the ions which is present in the CaO. Name the constituent metals of the bronze. The bronze is made up of copper and tin. A metal X acquires a green color coating on its surface on exposure to the air. So identify the metal X and then name the process responsible for this change. So the metal is the copper. So the process we call it as a corrosion. The name and write the chemical formula of the green coating formed on the metal. So the basic copper carbonate, that is CuCO3.CuOH twice. List two important methods to prevent the process. So we can coat with the less reactive metal, and also it should be mixed with the other metals to form the alloys. Write the balanced equation for the reaction of aluminium when heated in the air. Write the name of the product. So 4Al plus CO2 gives 2Al2O3. The product formed is the aluminium oxide. The iron with the steam, name the product uptime. So 3Fe plus 4H2O steam gives Fe3O4 plus 4H2. So the product uptime we call it as iron 3 oxide. Iron 2 and iron 3 oxide. Calcium with water. Why does the calcium start floating in the water? Okay. So the calcium reacts with the 2H2O water, gives the CaOH twice plus H2. So the bubbles of the hydrogen stick to the surface of the metal. That is why it floats. So the bubbles of the hydrogen stick to the surface. Yeah. Write the balanced chemical equation for the following reactions. Dilute sulfuric acid reacts with the aluminium powder. Okay. So 2Al plus 3H2SO4 gives Al2SO4 thrice plus 3H2. Dilute hydrochloric acid reacts with sodium carbonate. So Na2CO3 plus 2HCl gives 2NaCl plus H2O plus CO2. Carbon dioxide is passed through the lime water. CaOH twice plus CO2 gives CaCO3 plus H2O. What is meant by rusting? With labeled diagrams, describe an activity to find out the conditions under which iron rusts. So the process in which iron reacts with the oxygen in the presence of the moisture to form the reddish brown coating of hydrated ferric oxide, that is Fe3 iron 3 oxide Fe2O3.XH2O activity. So now take three boiling tubes A, B and C. Pour some water in the test tube A, put iron nails in it and cork it. Pour boiled distilled water in another test tube B and put iron nails in it. Add 1 ml of the oil over it such that the oil floats over it and prevent the air from entering. Take some iron nails in the test tube C and put some anhydrous calcium chloride in it and cork it. Leave all the test tubes for 1 day and then observe. The iron nails get rusted in the test tube A because of the presence of the air and as well as the water. The iron nails do not get rusted in B because there is a water but no air. And in the sea, the rusting will not take place because there is neither air nor water. So conclusion, the iron gets rusted in the presence of the air and the water. Show the formation of the Na2O by the transfer of electrons between the combining the atoms. Why are ionic compounds usually hard? Okay. So now first the formation of the sodium oxide. So the sodium is having the one electron in the outermost shell and the oxygen needs two electrons to complete the outermost shell. So the two sodium atoms are losing their two electrons and it is gained by the oxygen atom and it forms Na plus and the oxygen 2 minus. Why are ionic compounds usually hard? Because it is due to the strong forces of the attraction between the oppositely charged ions. So how is that ionic compounds in the solid state that do not conduct electricity but they do so when in the molten state? So because in the solid state the ions are not free to move, whereas in the liquid state or in the molten state the ions can be free to move. So they conduct electricity in the molten state. Show on a diagram the transfer of electrons between the atoms in the formation of the magnesium oxide. Write symbols of the cation and anion present in the magnesium oxide. So the Mg is present in the group 2, which is having the 2 electrons in the outermost shell. Oxygen, which is present in the group 16, so it's having a 6 electrons in the outermost shell. So the magnesium can able to lose the 2 electrons, the oxygen can able to gain the 2 electrons to complete the outermost shell. So the 2 electrons are transferred from the magnesium to the oxygen and it forms the Mg2 plus and oxygen 2 minus. The MgO contains Mg2 plus as a cation and oxygen 2 minus as anion. Name the solvent in which the ionic compounds are generally soluble. So the ionic compounds are soluble in the water. So why are the aqueous solutions of the ionic compounds able to conduct the electricity? It is because the aqueous solution consists of the ions which can move freely in them and can carry the current. What are amphoteric oxides? Choose the amphoteric oxides from among the following oxides. Okay. Na2O, ZnO, Al2O3, CO2, H2O. Those oxides which reacts with the acids as well as the bases to produce the salt and the water are called the amphoteric oxides. So example, Na2O, Al2O3 and the ZnO are the amphoteric oxides. The remaining Ne2O is a basic oxide and the CO2 is the acidic oxide. Define the terms mineral, ore and gangue. Okay. Mineral. It is a naturally occurring substance from which metal may or may not be extracted profitably or economically. Example, aluminium cannot be extracted profitably from mica ore. It is a rocky material which contains the sufficient quantity of the mineral so that the metal can be extracted profitably. See for example, zinc blende is an ore of the zinc from which the zinc can be extracted profitably. Gangue. It is a rocky material which is present along with the mineral in the ore. Say for example, FeO is a gangue in the extraction of the copper. Write the chemical name of the coating that forms on silver and the copper particles. Then these are left exposed to the moist air. So that is silver sulfide Ag2S is formed on the silver. Basic copper carbonate CuCO3.COH twice is formed on the copper. Explain what is galvanization, what purpose is served by it. So the process of coating the zinc over the iron, we call it as a galvanization. It is used to prevent the rusting of iron. Define an alloy. How are alloys prepared? How do the properties of the iron change when small quantity of the carbon, nickel and the chromium are mixed with it? So the alloy is a homogeneous mixture of two or more metals. One of them can be a non-metal. The alloys are prepared by melting the two or more metals together. Iron does not rust on adding the small quantity of the carbon. When we form the alloy of iron with nickel and the chromium, we get stainless steel, so which is malleable and does not get rusted. So differentiate between the roasting and the calcination. Explain the two with the help of the suitable chemical reequations. How is the zinc extracted from its ore? Okay. So roasting. Roasting is nothing but it is a process in which the sulfide ore is heated in the presence of the oxygen to convert into its oxide. So 2ZnS plus 3O2 gives 2ZnO plus 2SO2. Calcination. So it is a process in which the carbonate ore is heated in the absence of the air to form the oxide. So ZnCO3, when we are heating it, so it will liberate the carbon dioxide gas plus ZnO as a solid. By reduction process, zinc can be extracted from its ore. So ZnO we can also treat with the carbon, which is a reducing agent. So here it will convert into the zinc plus carbon dioxide gas. They name the two metals that can be used to reduce the metal oxide to the metals, aluminium and magnesium. In the formation of the compound between the two atoms A and B, A loses the A loses the two electrons and B gains the one electron. So what is the nature of the bond between the A and the B? So it's an ionic bond because the A is having a plus 2 charge and B is having a minus charge because one is losing, another one is gaining. Suggest on similar lines, explain the formation of the magnesium chloride molecule. Okay, so the magnesium loses the two electron and it forms the Mg2 plus, and the same time two chlorine atoms can gain the two electron and it forms the 2Cl minus. The common salt conducts electricity only in the molten state. Why? So the common salt is nothing but it is a sodium chloride which contains Na plus and the Cl minus. So are free to move in the molten state but not in the solid state. Why is the melting point of NaCl high? It is due to the strong electrostatic attraction between the Na plus and the Cl minus. The carbon cannot be used as the reducing agent to obtain the magnesium from a magnesium oxide. Why? It is because magnesium is stronger reducing agent than the carbon. How is the sodium obtained from the molten sodium chloride? Give the equation of the following reactions. Okay, sodium is obtained from the molten NaCl by electrolysis. So the 2 NaCl on electrolysis gives so 2Na plus chlorine gas. So 2Na becomes the solid. It will go near the cathode and the Cl2 is liberated at the anode. How is copper obtained from its sulfide ore? Give equations of the reaction. The copper ore is concentrated by the flotation process. So, roasting. So 2Cu2S plus 3O2 gives 2Cu2O plus 2SO2. Besmerization. So copper oxide reacts with the copper sulfide on heating to form the blister copper and the SO2. So Cu2S plus 2CuO gives 6Cu plus SO2. The blister copper is purified by the electrolytic refining. How is the method of extraction of the metals high up in the reactivity series differ from that of the differ from that of the metals in the middle? Why the same process cannot be applied for them? Explain giving equations the extraction of the sodium. So the metals high up in the series are obtained by electrolytic reduction because these metals are strong reducing agents and therefore cannot be obtained by the chemical reduction. The metals in the middle of the series are less reactive and can be obtained by the chemical reduction. The same process cannot be used for both of them as the highly reactive metals cannot be obtained by the chemical reduction. So always the high reactivity series have to obtain only by the electrolysis, and the medium reactivity series, which is in the middle in the reactivity series, so that will get by only by the reduction using the carbon or carbon monoxide. Extraction of the sodium is done by the electrolysis of the molten sodium chloride. So 2NaCl upon electrolysis gives 2Na plus Cl2. Write the names and the symbols of two most reactive metals. Explain by drawing the electronic structure how any one of the two metals react with the halogen. State any four physical properties of the compound formed. Answer. So the potassium and the sodium, which are the most reactive metals, which is present in the group 1. The K plus and the Na plus are the electronic structures as they have only one electron. So the K, which gives one electron to the fluorine atom, because the fluorine is having a 7 electrons in the outermost shell, so it will gain the electrons from the potassium, so K plus and F minus. So next one is sodium, so which is having a 1 electron in the outermost shell, so which can able to lose the 1 electron to the fluorine, and it forms the Na plus and the F minus, where F is a halogen. Four physical properties of the compounds formed by the elements and the halogens are: they have high melting point, they are soluble in the water, they conduct electricity in the molten state, not in the solid state, so they are solid and somewhat hard. A metal M, which is one of the best conductor of heat and the electricity used in making electric wires, is found in nature as sulfide ore M2S. So name the metal M. So it is a copper. So the roasting. So roasting means, so we have to roast the means copper in the presence of the oxygen. So the sulfur dioxide gas will come out and it forms the Cu2O. So 2Cu2S plus 3O2 gives 2Cu2O plus 2SO2. Decimalization 2 Cu2S plus 2 CuO gives 6 Cu plus SO2. Which process will be suitable for extraction of this metal M from its ore M to S? Write the balanced chemical equations. Okay. So it is concentrated by the flotation process. The impure copper is purified by the electrolytic refining. So with the help of the labeled diagram, explain the process of electrolytic refining of the metal. Okay. So the impure metal is taken always as the anode, whereas the pure metal is taken as a cathode. So the soluble salt of the metal is taken as the electrolyte. When the electric current is passed, the impure metal changes to the ions, which gains the electrons at cathode and change it to the pure metal. So the impurities are left behind as a anode mud. So at anode, so the metal gives n plus charge plus n electrons, so which is the impure. At cathode, the reverse reaction takes place. So the Mn plus will gain the electrons and it deposits as a metal. So this is the electrolytic refining. So this is the impure metal which acts as the anode, which is the pure metal acts as a cathode. So negative charge which we have connected, we call it as a cathode. The positive charge which we have connected, we call it as an anode. Give reasons for the following. Silver and copper lose their shine when they are exposed to air. Name the substance formed on the surface in each case. The metals got corroded. The silver forms the black AgS, that is the silver sulfide, and copper form greenish layer of the basic copper carbonate, that is CuCO3.CuOH twice. The tarnished copper vessels are cleaned with the tamarind juice. So the tamarind contains the acid which reacts with the basic copper carbonate and product gives the dissolved and removed from the copper vessel. Aluminium is more reactive than the iron, yet there is a less corrosion of the aluminium as compared to the iron when exposed to the air. Aluminium forms the oxide layer, that is the Al2O3 on the surface, so which does not further react with the air, which acts as a protective layer. Write the electron dot structures of sodium, oxygen and magnesium. Okay. So the sodium is having only one electron, so we have to write only one electron. Oxygen, which is having a 6 electrons in the outermost shell, so we have to write 1, 2, 3, 4, 5, 6. Magnesium, which is having a 2 electrons, so we have to write 2 electrons in the magnesium. show the formation of Na2O and MgO by transfer of the electrons. Name the ions which is present in the compound. So Na is having a 1 electron in the outermost shell. So oxygen is having a 6 electrons in the outermost shell. So now the two sodium ions loses the 1 electron each to the oxygen atom and it forms the two Na plus and the O2 minus. In the case of the magnesium, it's having a 2 electrons in the outermost shell, so they can easily lose the 2 electrons and it forms the Mg2 plus charge. So the oxygen, they can able to gain the 2 electrons. So Mg gives 2 electrons to the oxygen and it forms the Mg2 plus and the oxygen 2 minus. So Ne2O contains the Na plus and the O2 minus and the MgO contains Mg2 plus and the O2 minus ions. List the three properties of the ionic compounds. So they are solids at room temperature and are having a high melting point and they are readily soluble in the water and they conduct the electricity in the molten state as well as in the aqueous solution. What are alloys? How are they made? Name the constituents and the uses of brass, bronze and the solder. Okay. The alloys are nothing but it's a homogeneous mixture of two or more metals. So one of them can be a non-metal also. So they are made by melting a metal which is in a large amount first and then adding the other metal. The brass contains the copper and the zinc. So it is used for making the decorative articles. The bronze contains the copper and the tin. So it is used for making the statues and the medals. Solder contains the lead and the tin. It is used for the soldering purposes. A metal E is stored under the kerosene when a small piece of it is left open in the air, it catches the fire. When the product formed is dissolved in the water, it turns a red litmus to blue. Name the metal E. So E is the sodium, so which catches the fire in the presence of the moisture. So write the chemical equation for the reaction when it is exposed to the air and the product which is dissolved in the water. Okay, so 4Na plus O2 gives 2Na2O. So the 2Na2O is the product which has to be dissolved in the water, will get the sodium hydroxide. Okay. Explain the process by which the metal is obtained from its molten chloride. Okay, electrolytic reduction we have to do because it is a high reactivity serious metal. The electric current is passed through the molten NaCl. So the sodium is deposited at the cathode and the chlorine gas is liberated at the anode. The equation is 2NaCl which is in the molten state. When upon electrolysis we'll get the 2Na plus Cl2 gas. Write the two differences between the calcination and the roasting. So calcination is nothing but it is carried out by heating ore in the absence of the air. Roasting is it is carried out by heating ore in the presence of the air. Calcination converts the carbonate ore into the oxides. Roasting converts the sulfide ores into the oxides.